तो हेलो एवरीवन, स्वागत है आप सभी का मेरे यूट्यूब चैनल पे। सो द टॉपिक ऑफ द टुडेज वीडियो इज़ वी आर गोइंग टू डिस्कस ऑन द टॉपिक ऑफ LSTM, विच इज़ बेसिकली स्टैंड्स फॉर द लॉन्ग शॉर्ट टर्म मेमोरी. Long short term memory, it is a basically type of RNN. So LSTM is what? Basically it is a type of RNN. Now the prerequisite for starting with this particular video is you have a basic idea of the RNN networks. If you don't have the idea of RNN, please go through the RNN and that's come on, and after that you can come on this video. That would be better for you, for your understanding. So let's first discuss the basic idea of the RNN. That's how RNN is working. And so in a RNN, if you are saying so, like shown here in the RNN, you have one RNN unit like this. You have input, you have output, and here is the feedback. So same diagram is replaced here. If you expand this whole term according to timestamp, then you have this particular term. You have output corresponding to this, sending a feedback, input, output, feedback, input, output, and likewise so on. RNN is going on. So let's consider one real life scenario. Okay, fine. Let's consider one real life scenario. Let's assume that you are a traveler. I'm going to telling you a story. So अभी एक story बताने जा रहा हूँ मैं आपको. Can listen to this particular story carefully. That would be giving you a better intuition or a better idea on the topic of LSTM. एंड आप क्या करते हो कि आप मल्टीपल सिटीज़ में घूमते रहते हो, ठीक है. इस बार लेट्स से आप यू प्लान दैट यू विजिटिंग टॉप 10 पॉपुलर सिटीज़ ऑफ इंडिया लाइक बॉम्बे, दिल्ली, कोलकाता, अहमदाबाद, गांधीनगर, एंड वॉट एवर. Like you are going to plan visit of top 10 cities of India. टॉप 10 सिटीज़ ऑफ इंडिया का अगर आप विजिट प्लान कर रहे हो तो इनिशियली आप पहले किसी एक सिटी में जाएंगे, फिर सिटी नंबर 2 में जाएंगे, फिर सिटी नंबर 3 में जाएंगे, एंड सो ऑन आप सिटी नंबर 10 में जाएंगे. तो ये पूरी प्रोसेस जो होगी वो टाइम स्टैम्प वाइज होगी कि मान लीजिए कि डे नंबर 1 पे आप गए सिटी नंबर 2 पे, एंड देन डे नंबर 5 के आप गए सिटी नंबर 2 पे, डे नंबर 10 पे गए आप सिटी 3 में, क्योंकि ट्रैवलिंग टाइम एंड ऑल मिला के अगर दो सिटी के बीच का गैप 5 दिन आ रहा है. सो ऐसे करते 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 आप डे नंबर 10 पे पहुँचे सिटी नंबर 10 के अंदर. So this is a basically simple recurrent neural network kind of structure. Let's at t equal to 1 you have input as x1. At t equal to 1 means day 1 you have input as x1, and आप पहले सिटी में घूमे, आपने पूरा सिटी का निरीक्षण किया, एंड देन यू फाउंड समथिंग कि अच्छा ये इस सिटी के बारे में मेरा फीडबैक है. सो यू कीप गोइंग ऑन लाइक दिस. So this is a RNN like structure. You can understand at t equal to that particular, and it is a timestamp. This is a RNN unit simply showing in here. So इसमें क्या प्रॉब्लम है इन दिस पर्टिकुलर RNN में? अगर आप लोग देखें तो we have two problem. One is a long term dependency problem. Let's consider an example. Let's consider this particular example. Let's say you are planning to visit 100 सिटी में अगर आप देखने का प्लानिंग कर रहे हैं तो क्या होगा? पहले आप सिटी 1 देखेंगे, फिर सिटी 2, देन सिटी 3, एंड देन आप यू कैन रीच आउट टू सिटी नंबर 100. प्रॉब्लम इज व्हेन यू आर एट पर्टिकुलर, लेट्स से व्हेन यू आर एट सिटी नंबर 18, you might forgot the detail of the city number 1 or 2, बिकॉज ये बहुत पहले आप देख चुके हैं, और अभी आप सिटी नंबर 18 जब कवर करने जा रहे हैं तो इट पॉसिबल कि आप सिटी नंबर 1 या 2 के बारे में बहुत कुछ डिटेल ऐसी भूल गए, बिकॉज इट इज़ अ वेरी लॉन्ग टर्म डिपेंडेंसी. Yes, if you are at city number 18 and it is might possible if someone asks you about the city number 70 or city number 72, so this is the closest cities which अभी आप करंट जिस सिटी में उससे प्रीवियसली क्लोज सिटीज ये सब है कि आपने पीछे ये सब घूमे थे, तो इस सब सिटी के बारे में याद होगा। बट व्हेन समवन आस्किंग अबाउट द लॉन्ग टर्म कॉन्टेक्स्ट मीन्स बहुत पहले जो आपने सिटी देखी, इट माइट पॉसिबल कि आप बहुत कुछ चीज़ें भूल गए होंगे। सेम प्रॉब्लम इन द RNN is also that if the sequence is keep going on and keep going on, then at that particular timestamp, if I'm asking about some previous information which is come too much earlier in the particular our model, so you might possible that you don't you forgot all of the information about the initial states. This is a problem of long term dependency, and RNN did not able to handle the long term dependency. This is a problem of RNN itself. So ये तो प्रॉब्लम हो गई, what we can do. So basically due to this, अगर if we talking in a more technical way, so because of this particular long term dependency, लॉन्ग टर्म डिपेंडेंसी की वजह से क्या क्या प्रॉब्लम हो सकता है? फर्स्ट इज अ वेनिसिंग ग्रेडियंट प्रॉब्लम, सेकंड वन इज अ एक्सप्लोडिंग ग्रेडियंट प्रॉब्लम. Vanishing gradient problem means, if you again if you don't have understanding of what is a vanishing gradient problem, what is exploding gradient problem, please look at this concept and then come on this particular video. So what is a vanishing gradient problem? Your weights up, it's not happen means your weight are not going to change, because when going in a long term sequence at a particular point of time, if you are back propagating in this particular, let's say you back propagation apply in this particular channel, so you in some of the state it is a, you can if you multiply your weights with a very small values and all, so because of this your new weight in this particular problem, your gradient is near to zero. your gradient आपके जीरो के नियर हो जाएंगे, एंड बिकॉज ऑफ दिस पर्टिकुलर वीडियो योर वेट अपडेट्स नॉट हैपन, बिकॉज your weight new is equal to weights of old minus learning rate time gradient value. If your gradient value is zero, then this particular entire, not zero, but if it is near to zero also, so this particular value is also become near to zero. And if you subtracting something very close to zero, that doesn't impact on your new weights, means your W new and W weights have become almost similar. This is a vanishing gradient problem. एंड सेम वे एक्सप्लोडिंग ग्रेडियंट, वेनिसिंग ग्रेडियंट मीन्स ग्रेडियंट ही वेनिस हो गया जीरो या क्लोज टू जीरो. एक्सप्लोडिंग ग्रेडियंट मीन्स टू लार्ज वैल्यू ऑफ ग्रेडियंट. So due to this your training is not stable training and your ultimate outcome is not good. This is a two problem associated with the RNN. If you are don't understanding about this, please look at this concept and then come on the video. Now question comes in your mind is, what is the solution and how this particular LSTM, means LSTM stands for the long short term memory, how LSTM solve this particular problem. So let's start discussion on this. Okay, so here I shown it is a simple RNN architecture which is shown here. So in this particular you have input, output and feedback. It's simple like this: input, output and feedback connection. So if I'm drawing here it, then this is the output, this is the input, and here is the hidden state, means feedback. This is a simple RNN. But when we talk about the LSTM, so what we want is, eventually, let's take one more example, not taking an extra example. Let's take a previous example of the cities. Let's say you are visiting a city number 1. Instead of remembering all of the information about the city number 1, like कौन से places अच्छे थे, खाना अच्छा था, city का all over culture कैसा था, environment कैसा था, बहुत सारी information हो सकती है एक city के बारे में. तो instead of remembering this all of information, what we can do is we can remember some important information about this city, because हमारे दिमाग में भी उतनी चीज़ नहीं रह पाएगी. एंड व्हेन वी कैलकुलेट इन टर्म्स ऑफ द कंप्यूटर, सो मेमोरी इज़ अ प्रॉब्लम. सो सब चीज़ एक छोटी मेमोरी में नहीं रह सकती. सो इंस्टेड ऑफ टेकिंग ऑल ऑफ द इंफॉर्मेशन अबाउट दिस सिटी 1, व्हाट वी कैन डू इज वी कैन ओनली टेक important information of this city and store in mind, in terms of computer, store in memory. So now you have very precise data about this city 1. While visiting a city 1, you can note some important information of this particular city, which is the famous things and all, and you can only store this particular important or meaningful information, not storing unnecessary thing about this particular city. Now you can move on city number 2. Same process, important things store in your memory, and now go in the city number 3. Same process, important things capture karo and then store in the mind, means store in your memory, anywhere. So while visiting, let's say city number 100, capture information, store in the mind, store in your mind. This is how we are trying to do this particular problem. What you can doing is, firstly what we are doing is कि पहले हम एक पूरा सिटी को विजिट कर लेते हैं. You are visiting entire thing, when you, it means you are go through the all of the information, all of things in this particular city. From this all of this information, you are only maintaining fewer information about that particular city. So in the RNN itself, we are doing something like this. We are going forward and sending a feedback to this particular network. This feedback back to particular, it's also work as an input like shown here. बट इसमें प्रॉब्लम क्या था कि अगर आप सिटी ए में घूम रहे हो तो उसकी सारी इन्फॉर्मेशन स्टोर कर रहे हो, आगे जा रहे हो, देन अगेन विजिटिंग अ नेक्स्ट सिटी, सारी इन्फॉर्मेशन स्टोर की, देन मूव फॉरवर्ड एंड ऑल. सो सारी इन्फॉर्मेशन स्टोर करने में ड्रॉबैक इज यू आर रिमेंबरिंग द प्रीवियस इन्फॉर्मेशन बिकॉज यू हैव कंस्ट्रेंट ऑन अ मेमोरी. आपका दिमाग या आपकी हम मेमोरी में इन्फाइनाइट लेवल ऑफ डेटा नहीं स्टोर कर सकते. तो सॉल्विंग दिस पर्टिकुलर प्रॉब्लम व्हाट वी आर थिंकिंग इज कि इंस्टेड ऑफ रिमेंबरिंग ऑल ऑफ दिस थिंग्स, we are only remembering the important things about the city. So that's why RNN comes in the picture. So important things, if you are only storing the important things, then what happen is whenever you needed some information about that particular city, you can directly fetch the information from your memory or mind, and you can deliver to anywhere wherever you need this particular information. This is the core concept behind the LSTM. Now let's again take understanding of RNN. So what happened in the RNN is, so simple, not RNN but understanding of LLM. So यहाँ तो मैंने simple RNN draw किया. Now I'm going to draw the simple intuitive architecture of the LSTM. So basically you have LSTM block, same way input, same way output. Let's consider this for now on. इनपुट आउटपुट, एंड यहाँ से आप एक और फीडबैक सेंड करते थे जो यहाँ पे है वो. बट नाउ इंस्टेड ऑफ सेंडिंग वन फीडबैक, यू आर मेंटेनिंग अ टू कॉन्टेक्स्ट. यू आर मेंटेनिंग अ टू कॉन्टेक्स्ट मीन्स एक और फीडबैक जाएगा. सो दिस फर्स्ट वन, दिस इज अ शॉर्ट टर्म विच इज़ वर्क इन सिंपल RNN, कि ये वाला जो है शॉर्ट टर्म है, और ये है जो है लॉन्ग टर्म. सो इस वाले कॉन्टेक्स्ट में आप क्या करेंगे, जो भी इम्पोर्टेंट इन्फॉर्मेशन होगी वो हम इस वाले कॉन्टेक्स्ट में रख लेंगे. सो वेन एवर वी नीडेड आफ्टर अ लॉन्ग टाइम, इफ दिस इंफॉर्मेशन इज रिक्वायर्ड, वी कैन एक्सेस दिस पर्टिकुलर इम्पोर्टेंट इन्फॉर्मेशन फ्रॉम दिस लॉन्ग टर्म कॉन्टेक्स्ट एंड given as a output whenever we require. This is a whole intuition behind the LSTM. I hope you understand. Now for this, कि आपको दो कॉन्टेक्स्ट मेंटेन करने हैं. इफ़ यू आर विजिटिंग अ सिटी, देन जस्ट रिमेंबरिंग ऑल ऑफ दिस थिंग्स, यू आर ओनली रिमेंबरिंग सम इम्पोर्टेंट थिंग्स. इससे फ़ायदा क्या होगा कि आपका जो भी काम की इंफॉर्मेशन होगी वो वेनिश नहीं होगी आफ्टर लॉन्ग टर्म डिपेंडेंसीज ऑल्सो. नाउ द क्वेश्चन कम्स इन योर माइंड्स कि now let's discuss in terms of technical. So let's say you are passing an entire paragraph of let's say words. इतने बड़ा पैराग्राफ आप एक RNN नेटवर्क में पास कर रहे हैं. सो एट t=1 टाइम स्टेप पे आपका वर्ड 1 आएगा. ऐसे ही लेट्स से t=1 पे आपका आएगा वर्ड नंबर 1, लाइक शोन इन हियर. t=1 पे x1 इनपुट आएगा, t=2 पे x2 इनपुट आएगा, t=3 पे x3 आएगा, ऐसे t=n पे xn इनपुट आएगा. सो व्हाट इज हैपनिंग, शॉर्ट टर्म कॉन्टेक्स्ट से तो हम सारी इन्फॉर्मेशन पास कर ही रहे हैं, लाइक शोन इन हियर, all of the input are passing it and sending a feedback, means here it is sending a feedback to it. But what we can do is, इससे जब हम सारी इन्फॉर्मेशन प्रोपोगेट कर रहे हैं एंड इफ यू फाउंड समथिंग यूजफुल इन दिस पर्टिकुलर कॉन्टेक्स्ट, देन वी आर storing the long term context so that we can access this particular information after a long time also. Let's say वन मोर एग्जाम्पल, एक सिटी वाले एग्जाम्पल ही कंसिडर करते हैं कि आपने सिटी को घूमना चालू किया, ये सिटी वन है, आपने उसको घूमना चालू किया. सो यू आर विजिटिंग द ऑल ऑफ द प्लेस यू कैन हर्ड अबाउट इन द सिटी, लाइक किसी ने बोला सिटी में एक किला है, दिस इज़ अ रेस्टोरेंट, ये पार्क है, फिर वॉट एवर, लाइक ये ज़ू है, ये म्यूज़ियम है. बहुत सारी सिटी, इसमें बहुत सारी सिटी में चीज़ें हो सकती है, म्यूज़ियम, पार्क, ज़ू, होटल, टेम्पल, सो एंड सो और मैनी मोर चीज़ें हो सकती है. तो आप तो क्या करेंगे, आप तो वन बाय वन ही सबको घूमते रहेंगे. बट लेट्स से यू फाउंड दैट कि यार म्यूज़ियम इज़ लाइक ग्रेट, बहुत अच्छा म्यूज़ियम सा. तो आप पहले से यहाँ पर से आपका म्यूज़ियम हुआ होगा, तो आप क्या करेंगे, आपकी डायरी में लिख लेंगे कि अच्छा ये अच्छी चीज़ है. देन यू विजिटिंग अ पार्क एंड यू फाउंड दैट पार्क इज़ नथिंग, इट्स जस्ट सिंपल लॉन एंड ऑल्सो दिस इज़ अ नॉट मच. तो इसको आप क्या करेंगे, आपके लिस्ट में ऐड नहीं करेंगे. जू यू आर ऑल्सो फाइंड दैट दिस इज़ नॉट दैट मच ऑफ गुड लेवल ऑफ जू, इट्स सिंपल, वेरी सिंपल, और नॉट कि उतनी अच्छी जू नहीं थी, उस हिसाब से आप उसको भी क्या करेंगे, फिर नहीं रखेंगे. फिर आपको कोई बोलेगा कि अच्छा ये होटल है, वो फिर आपको, आप जू से निकले, आपको रास्ते में किसी ने बोला कि भैया इस सिटी में ये होटल बहुत बढ़िया है, ये होटल बहुत बढ़िया है, आप एक बार उसका खाना ज़रूर ट्राई करना. तो आपने क्या किया, अभी अपनी लिस्ट के अंदर, लेट से हम मेंटेन करें सिटी वन के बारे में लिस्ट, तो सिटी वन में पहले तो आपको म्यूज़ियम अच्छा लगा था, तो आपने म्यूज़ियम को ऐड कर दिया अपने लिस्ट में. नाउ आप घूमते 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 जा रहे हैं और किसी ने बोला कि ये होटल बहुत अच्छी है हमारे सिटी की, दिस इज़ वन ऑफ द मोस्ट फेमस रेस्टोरेंट ऑफ आवर सिटी एंड फूड इज़ वेरी गुड, वेरी एक्सलेंट फूड. सो यू आर प्लानिंग टू विजिट दैट पर्टिकुलर होटल. यू आर, पर विजिट करने के लिए आपको क्या करना पड़ेगा, लेट्स से कि आपने उसको डायरी में ऐड कर दिया अपनी होटल. सो नाउ आपको याद रहेगा कि अच्छा मुझे होटल विजिट करनी है. ओके, आपने होटल को विजिट किया, आपको खाना कुछ सही नहीं लगा. सो नाउ यू व्हाट यू कैन डू इज़, यार बातें तो बड़ी सुनी थी पर काम ऐसा नहीं है, बातें बड़ी और काम छोटे. इस होटल के बड़ी बड़ी बातें सुनी, खाना उतना कुछ खास नहीं था, तो इस सिटी की इम्पोर्टेंट इन्फॉर्मेशन की लिस्ट में मैं इस होटल को नहीं रख सकता हूँ. सो व्हाट यू कैन डू इज़, you can simply remove the hotel from this list. Now again you visiting hotel khatam, temple you found, oh it's a good temple, very good temple, nice to visit a place, very peaceful things and all, kala akruti and all is very good in this particular temple. So you can store temple. So अब आपके पास क्या है कि इस सिटी के बारे में पूरी इन्फॉर्मेशन होने के बजाय इम्पोर्टेंट देखने लायक इन्फॉर्मेशन आपके पास है, सो दैट यू कैन स्टोर इट फॉर अ लॉन्ग टाइम. ऐसे ही आप सिटी टू में जाएंगे, सिटी टू की इन्फॉर्मेशन स्टोर करेंगे, सिटी थ्री में जाएंगे, सिटी थ्री की लिस्ट बनाएंगे, तो फाइनली यू हैव वन सेंट्रलाइज्ड लिस्ट जिसमें सिटी वन की इन्फॉर्मेशन, सिटी टू, सिटी थ्री, सिटी फोर, सारे सिटीज़ की इम्पोर्टेंट इन्फॉर्मेशन आपके पास होगी. तो इस पे दो चीज़ें हो रही है कि इस वाले कॉन्टेक्स्ट से तो सारे फीडबैक जा रहे हैं, बट फ्रॉम दिस फीडबैक यू कैन कैप्चर इम्पोर्टेंट थिंग्स विच नीड टू कैप्चर फ्रॉम दिस पर्टिकुलर फीडबैक, ताकि ये आगे जाके वेनिश ना हो जाए. सो वी कैन कैप्चर इम्पोर्टेंट थिंग्स फ्रॉम दिस पर्टिकुलर कॉन्टेक्स्ट एंड स्टोरिंग इन अ लॉन्ग टर्म कॉन्टेक्स्ट. अब मैंने जैसे आपको होटल वाला एग्जांपल दिखाया कि इट माइट पॉसिबल कि इस पर्टिकुलर टाइम स्टैम्प के यू फाउंड कि ये इंपॉर्टेंट है, बट आफ्टर अ सर्टन पीरियड ऑफ टाइम यू फाउंड दैट दिस इन्फॉर्मेशन इज़ नॉट हेल्पफुल, बिकॉज जैसे आपको लगा कि होटल बेकार था, दोबारा जाने लायक नहीं, तो आपने सिटी के लिस्ट से होटल को हटा दिया था. You remove the hotel from the list of these important places of the city. Same way में what you can do is, if you found something unnecessary in long term context, you can also remove this from the long term context also. So what we are eventually doing is we are trying to maintaining the long term context. What we are doing is we are trying to maintaining a long term context, means storing a important information. So maintaining means remove plus add. If you found something helpful, then you can add, and if after a certain period of time if you found that this particular information which I added previously is not that much of helpful, you can simply remove those information. This is a core intuition behind the LSTM. You are maintaining a long term short term context as well as the long term context both. Now you also require the communication channel between long term and short term context. So how this communication channel works and all this we are going to discuss in this particular video itself. So be patient and be with me in this particular video. You have a very good idea and understanding of the topic of LSTM, that's my guarantee. Now if you are comparing LSTM with RNN, so in RNN, so let's say here I am writing a point of RNN here. So in RNN we only have one channel means we only have this चैनल. सो ये तो कौन सी चैनल थी अपनी शॉर्ट टर्म वाली, जिसमें तो चीज़ें आती थी, नियर बाय चीज़ें याद रहती थी एंड ओल्डर चीज़ें जो थी वो हम भूल जाते थे. बट LSTM में क्या है, जैसे यहाँ पर ये एक है, LSTM में जैसे क्या है यहाँ पर दो चैनल्स है लाइक सोनी नियर हियर हियर हियर. सो हम क्या बोलते हैं कि RNN में तो सिर्फ नो लॉन्ग टर्म कॉन्टेक्स्ट इन RNN, long term context, but in the LSTM there is a short term context as well as long term context, both are there. Okay, second thing is architecture. Architecture is simple, like shown in this particular picture. We only have one neural network with the 10H activation function, but whereas in LSTM we have these complex architecture containing a many operation, many neural network operation, and then activation function, point wise operation. So complex architecture. And you can also understand, like here in the LSTM we only have one channel, but in the RNN we only have one channel, but whereas in LSTM we have two channels. One is a short term and one is a long term, when we will also have to establishing a communication between these two channels, so they can communicate and adding and removing information from the long term and short term context. So that's why you can also understand कि ये काम करने के लिए जो आर्किटेक्चर चाहिए रहेगा वो थोड़ा कॉम्प्लेक्स रहेगा. सिंपल चीज़ों से सिंपल काम होगा, कॉम्प्लेक्स आर्किटेक्चर से कॉम्प्लेक्स काम होगा. सो दैट्स वाई आर्किटेक्चर ऑफ द LSTM इज ऑल्सो कॉम्प्लेक्स देन LSTM. Then we are moving on the architecture of the LSTM. So moving forward for the architecture, firstly I'll encourage you to do not learn this entire picture at this one. I break down this entire picture in a small chunk and explaining everything to you, so it's easier. अभी ये बड़ी पिक्चर देख के डर मत जाना कि ये कॉम्प्लेक्स सी चीज़ क्या आ गई, क्योंकि कॉम्प्लेक्स तो आटा होता है, हम तो सिंपल करके समझेंगे इसको. सो अभी हम क्या करने जा रहे हैं कि इस पूरी चीज़ को मैं पॉइंट बाय पॉइंट आपको पढ़ाऊँगा. ओके, नाउ पहले इस पूरी चीज़ को समझने से पहले यू हैव टू अंडरस्टैंडिंग अबाउट द कॉम्पोनेंट ऑफ दिस पर्टिकुलर. सो forget about this architecture. Whatever I am explaining right now, you can just remember these things. Okay, so in this particular image, you have like this one is something happening here, this is something happening here, this is something happening here, this. So ये क्या है, ये सब चीज़ें है क्या, उसको एक बार हम पॉइंट बाय पॉइंट समझते हैं. तो जैसे कि ये सब जैसे चीज़ें हैं कि यू फाउंड समथिंग कि ऐसा लिखा है आपके पास. सो इट इज़ अ पॉइंट वाइज मल्टीप्लिकेशन ऑपरेशन. पॉइंट वाइज मल्टीप्लिकेशन ऑपरेशन मीन्स means you have a two vectors like 1, 2 and 3. This is a vector number 1 and this is a vector number 2, 3, 4 and 5. So in the pointwise multiplication, output vector is what? Your pointwise multiplication output is multiply 1 with 3, 2 with 4, 3 with 5. So what is your output? 3 into 1 3, 4 into 2 8, 5 into 3 15. So this is the output of this pointwise multiplication operation. Again, अभी ये मत पूछना कि क्या होता है, क्यों होता है, जस्ट अंडरस्टैंड द कॉन्सेप्ट. ओके, दिस इज अ पॉइंट वाइज मल्टीप्लिकेशन ऑपरेशन. Then we have one more operation in the entire architecture of LSTM. This one is a pointwise addition operation. Pointwise addition operation means if you found something like this in the architecture of LSTM, means this is a pointwise addition. Pointwise addition means simply 1 2 3. Here you have 4 5 6, these two vectors. And if you perform a pointwise addition operation in between these two vectors, then your final output is 4 into 4 plus 1 is 5, 5 plus 2 is 7, 6 plus 3 is 9. This is the output of pointwise addition operation. So in this particular architecture we have this one pointwise addition operation. Let me use other color. Okay, this is a one pointwise addition operation. We have one more pointwise multiplication, and then pointwise multiplication here also, pointwise multiplication here also. So this is all. Now इस पूरे आर्किटेक्चर में you have some other things as well, like let's firstly remove this. So what we done is we done with this. इतने component आपको अब तक समझ आ गए. That's what I believe is. And now let's discuss one more component. So you have some more components, like here it is SIG, this and this. Okay, so you have other component as well in this particular. What is that particular component is? So ये जो चारों है basically, if I am highlighting with red, sorry. So when you discuss about this four component, so this is nothing but a neural network. This is nothing but neural network. ये चारों जो है ये this is a neural network. Neural network with only one layer. Means we in a neural network you know that we have multiple hidden layers are there. One layer containing multiple neurons, and these are the connection. But in this particular LSTM architecture, this neural network are only have one layer. Means in one layer you have multiple neuron itself, but the layer is one. Means we only have a one hidden layer. Instead of having multiple hidden layer, input and output layer, we only simply have this one layer which containing a multiple neuron. यहाँ तक आई थिंक आपको समझ में आ गया. ये न्यूरल नेटवर्क है. इसमें फिर इफ़ यू आर लुकिंग, देन यू हैव these particular vectors. So this is one vector, this is another vector, this is one other, this is one another vector. Let's forget about these networks. The property of this neural network is this all four neural network have same number of neuron. All four neural network has same number of neuron. So if this particular neural network contain a 5 neuron, then this is also containing a 5 neuron, this also containing a 5 neuron, and this is also containing a 5 neuron in its architecture. Initially you have option to decide whether you have to choose a 4 neuron or 5 neuron, or let's say n number of neuron. But after deciding a fixed number, you have same number of neuron in all of the neural networks. So, and why you are keeping this all of number of neurons same in this particular neural network, that's I also explaining in the upcoming portion of this particular video. But till the point I think आपको इतना समझ में आ गया होगा. So अब तक हमने क्या क्या डिस्कस कर लिया. Let's summarize this. We have some operation in LSTM. Some are neural network operation, some are point wise operation. Which one is a pointwise operation? This is a pointwise multiplication. This is pointwise multiplication. On which value we are applying a pointwise operation? We are applying this pointwise operation are in between two vectors. So this is a multiplication operation. This is pointwise addition operation. This is a neural network. Again, this is a neural network. Again, this is a neural network. Again, this is a neural network. Now let's try to understand why here it is writing like SIG, 10H, SIG. Sigmoid means neural network with activation 10H. So let's say you have a 4 neuron in this one layer. So each has a 4 neuron in its one layer. This neural network, 4 neuron has the activation function sigmoid. If you are talking about this, so this is also neural network which has a 4 neuron and with the activation sigmoid. This is a neural network which has a 4 neuron and the activation function is 10H. This is the only difference. This is again a neural network with the activation sigmoid. This is a simple meaning of this. I hope till the point everything is clear to you. Now let's discussing about some of the important point in this. Firstly, I erase all the thing here. Okay. So be with me in this particular video. Initially, you found that it is a little bit difficult for understanding, but believe me, it's a very easy topic. I'll break down the entire architecture in the step-by-step portion so you can easily understand it. Now what happen is, इतने जो पोर्शन है वो हमने कवर कर लिया है. 1 2 3 4 5 6 7 इतना पोर्शन हमने कवर कर लिया है. Now question comes to your mind is, what is this? This is a point-wise 10H. So you have a 10H function, like let's say this is your 10H function, 10H of x. उसका फॉर्मूला होता है e एक्सपोनेंशियल के फॉर्म्स में. So point-wise 10H is performed on a single vector. Means let's say you given a vector with value 1 2 and 3. So what is the output of the point-wise 10H? 10H of 1, 10H of 2, 10H of 3. This is the output of point-wise 10H. Means this particular operation you don't require 2 operands, means 2 vector. You can apply this vector operation on a single vector unit. This is clear to you, that's I'm hoping. So at the last हमने ये भी cover कर लिया. Now comes on the very important point is this. This is basically like I mentioned in this particular RNN. What we have, if you are forwarding this entire thing in between, and let's remember this, then this output and feedback. Okay, so at this particular step, what we are doing is the output of that particular neuron is sent as back to the feedback, and then further process will be calculated. So after each layer, what we are calculating is output, and the same output is also feedback. So eventually we are calculating a feedback for the previous layer in this step. You understand what you getting what I'm trying to say is? So LSTM में what we have only one channel like this, and then here inputs corresponding to each hidden state. But you remember in LSTM what I'm saying is we have a 2 channel corresponding to each. So if I break down this entire things in a small part, let's remove this all things. So if I break down this entire architecture in a small part, so in the LSTM we have architecture like this. Let's do it on here itself. So simple LSTM में क्या था कि आपका ये था, इसको if you are opening this then you getting this. So in the LSTM what is our architecture is, here is LSTM unit, this we have two contexts, you remember, short term and long term. So if you expand this, then what we are eventually getting is this state with two feedback, बिकॉज यहाँ पर एक फीडबैक था, उसको एक्सपेंड किया तो ऐसे एक फीडबैक लाइन एक बन गया. So here we have two feedbacks. So here is also, if you expand, then you have two feedback. Here is the input corresponding to this. Initially we have some random feedback, and whatever layer you want your output, you have your output also based on the type of RNN, whether it is one to one, one to many, many to many, and all. So t equal to 2, t equal to 3, and all. So if you expanding LSTM, and this is a single unit of LSTM. This is a single unit of LSTM, likewise shown here. This is a single LSTM unit. Again, this is a single RNN unit. This is other. Weights are same, but this is a single RNN unit. This is a single unit. So same way, if you are take a architecture of single RNN, then you have input as a previous hidden state is your input. Likewise shown in here. Here is previous hidden state is your input, and current input. It means you have two input, previous state का feedback and your current input is your input, and based on that what you are calculating output. Output means a feedback for a next stage, input for a next level. So here is this only one output you have. But in the LSTM, what we are doing is we are maintaining a two contexts, short term and long term, both contexts. So at each step we have two outputs. One is a short term context, one is a long term context, and is a short term context. So in the LSTM, let's firstly discuss about the RNN also, कि RNN में हमारे पास क्या होता है. In RNN, as an input you have h of t minus 1 state का feedback and x of t means current state input and previous state feedback, and as an output you have value of h of t. This is a simple RNN. But in the LSTM, what you have is you are maintaining a two channel now. So as an input you also have a two channel, previous short term state and previous long term state. So c t minus 1 h t minus 1 and current stage input xt. This is a current state input, this is a previous term long term feedback, this is a previous short term feedback, and your output is current state का long term feedback means ct, and current state का short term means ht, hidden state and cell state. This thing you understand, input and output. In RNN you have only one output, whereas in LSTM you have a two output, because you are maintaining a two context. So for each context you need to output at each timestamp. This is clear to you, that I am hoping. What about the input? RNN you have two input, but whereas in LSTM you have three input, because maintaining a long term and short term context, you also require a previous states long term and short term context data also. Understand the topic? Okay. Now we are ready to move on the architectural portion of the LSTM. So here is this. I'll again repeating the architecture. So here you can see clearly, like this is what is this? This is a pointwise multiplication. This is pointwise addition operation. When we perform on which type of data we performing this operation? On vector data, means on a vector we are performing this operation. We have again this pointwise multiplication. We again have this pointwise multiplication. These four I'll telling is कि this is a neural network. This neural network with this is basically symbol of sigmoid neural network. This is a neural network with activation function sigmoid. This is a neural network with the activation sigmoid. This is a neural network with activation 10h. This is again a neural network with activation function sigmoid. One more property about this neural network is these all are have same number of neurons in its architecture, but same neuron doesn't mean that these all are same, but weights are different. weights are different means you understand what I'm trying to say is, let's say you have this, let's pick up this one. So this is like a 3-layer architecture, and it's giving you output number 1, output 2, and output 3, and as an input you have something like this. So the weights, basically we are multiplying the input with the weights in neural network. So each layer, each neural network, not each layer, each neural network had different weights that make it different from each other. Okay, so that's why it's a different neural network, because if your weights are different, then our output corresponding to the each neural network is also different, but the property is same number of neuron is same, but weights are different. That's make this each of the neural network different from each other. You have this ct minus 1, this is basically ct minus 1, and this is basically ht minus 1. This is ht and this is ct. So let me clear with this. So I mentioned in my previous talk is, in LSTM we have two contexts. One is a short term context and second one is a long term. शॉर्ट टर्म कॉन्टेक्स्ट को हम बुलाते हैं हिडन स्टेट. Likewise in LSTM you are also calling this as a hidden state. This is a hidden state in LSTM. So and short term context में what's happening, all of the information propagate to the short term context. So short term context is also known as hidden state, and that's why it is written here using the symbol of H. Long term context is also known as a cell state. So long term context को हम बुलाते हैं cell state. That's why here it is a name as C. It means it is symbolized as C. So now one more thing is clear to you. H means hidden state. Hidden state means short term context. C means cell state. Cell state means long term context. Okay, so don't confuse in between this. So again, what is this? We have cell state value of previous state, hidden state value of previous state. Now I am not using a word of long term and short term. Instead of long term, we are using name cell state, and instead of short term, we are using a name hidden state. So what is your input? Current timestamp input means x of t, and you have second input is previous state hidden state and previous LSTM cell state. And what you require as an output, you have two values like here, इस वाले particular cell state का cell state and current timestamp का hidden state. Means for this particular timestamp t equal to t, you need to maintain this cell state and calculation of this hidden state. Why I'm saying maintain this cell state? Because in the long term context, if you are remembering that we are storing some information, then removing some information according to time wise and according to our knowledge. So maintaining means adding or removing. So at each time step, we need to decide that which information are going store in the long term context and which information is unnecessary and we need to remove from this. That's why I'm using maintaining a long term and calculation of a hidden state for the current timestamp. Calculation for the hidden state for current timestamp and maintaining the long term context. Long term context means cell state indicated by C, and hidden state means short term context and hidden state is indicated by H. Till everything is clear. There is one more important property. Now you have question this, what is this C and H? So this C and H are also vectors. These are the vectors. These are vector with some property of same size. This both vector have same size. Means if C vector is size of 1 cross 5, then H vector is also size of 1 cross 5. Why these both vector are same, that we'll discuss in the upcoming portion of the video. But I hope that till the point everything is clear to you. So whatever what we are discussing is, this is a cell state means long term context. This is a hidden state means short term context. What is this CNH? CNH are the vectors. These and these vector have same dimension means same size, same dimension vector. So let's summarize all of things and end this particular video here. So in the LSTM architecture, why firstly we are using LSTM? To solve the problem of vanishing gradient problem and exploding gradient problem. How LSTM solve this problem? That we are going to discuss in our upcoming videos. But now what is the difference between LSTM and RNN? So in LSTM we have long-term context, but in RNN we don't have any long-term context. LSTM able to capture long-term dependency because of this long-term context, but RNN cannot able to capture a long-term dependency because it does not have any long-term context, and it's failing in maintaining a long-term dependency. Okay, clear these things. Now we are come on the point of LSTM architecture. So in LSTM architecture, what we found is we have some pointwise operation, we have some neural network operation in this, and using this particular operation we are calculating what is maintaining a cell state and calculating a hidden state for the current timestamp for t equal to t timestamp. क्या करते हैं हम इस पूरे आर्किटेक्चर में, आप देखें, इफ यू कैन सी, by performing all of this mathematical calculation, what we are doing is maintaining a cell state means long term context, and calculation value of a short term context means HT means hidden state. इतना आपको समझ में आ गया? So here I am going to end this particular video. In the next part of the video, we are starting with the architecture of LSTM. Original architecture of LSTM means we are going to discuss the concept of gates in LSTM. What is the input gate, what is the output gate, forward gate means forward gate, input gate, output gate, and all, and entire architecture of neural networks. We are also discussing why we are taking the same number of neuron in each neural networks, how to maintain this short term context, how we are adding something to the short term context, how we are adding something to this long term context, how we are adding something to this long term context. Sorry, sometime I call this short term as a long term. सो इन द नेक्स्ट वीडियो हम क्या देखेंगे कि ये सारे न्यूरल नेटवर्क सेम न्यूरॉन क्यों होते हैं, ये पूरे आर्किटेक्चर को समझेंगे, स्टेप बाय स्टेप क्या ऑपरेशन होता है, गेट्स क्या होते हैं LSTM में वो समझेंगे, एंड वन मोर इम्पोर्टेंट थिंग्स कि हाउ दिस शॉर्ट टर्म कॉन्टेक्स्ट इज नॉट शॉर्ट टर्म, हाउ दिस सेल स्टेट मीन्स लॉन्ग टर्म कॉन्टेक्स्ट इज गेटिंग कैलकुलेटेड, उसमें कुछ चीज़ को ऐड कैसे करते हैं, शॉर्ट लॉन्ग टर्म से कुछ रिमूव कैसे करते हैं, एंड ऑल ऑफ दिस. So this is all about this particular video. I hope you like this. Let's meet in the upcoming video with the LSTM architecture. Till then, स्वस्थ रहे, मस्त रहे, अपने अपने काम में व्यस्त रहे. Thank you very much for watching this video. Bye bye.